Okay, so we'll talk a little about uh, interference and grounding. Basically, what you do when you're interfering with uh, what they call a consumer electronics, somebody's TV or radio or stereo or your own. Um, I know for a fact that if I uh, key my handy talkie right here, I'll hear myself uh, very distorted on my speaker system, even though I'm transmitting on 2 meters. I'll hear the audio coming out of my speaker that's hooked up to my HF radio, which isn't even on. So it doesn't take all that much power. I mean, that's only, I think that particular one there is 10 watts, but it's probably less. So if you're doing single sideband, for instance, you may be causing distorted speech in somebody's audio equipment. Uh, Even if it was just a speaker that wasn't powered up, just the wires going to the speaker could pick up enough signal that actually uh, it would filter out the carrier frequency, and you just get the modulation part and actually have the distorted sound. If it was CW, then it's kind of like on and off hums and clicks since there's no audio there. So those are both things you have to watch out for. And we talk a little bit about some of the fixes. If your neighbor's complaining about that, then that's one of the things you're supposed to try to go and see what you can do to help, because you're more than likely the cause. But you may be able to do some filtering. In the case of a speaker, just attaching um, fairly a low value capacitor across the terminals would probably be enough to absorb the interfering signal so that you wouldn't hear it out of the speaker. You can put ferrite chokes, like in the picture, these clip-ons on all of the audio cables. That's a good thing to do regardless. Um, you almost can't have too many ferrite chokes on cables.
So
A lot,
does those go on your neighbor's stuff or your stuff?
both. If the neighbor's having a problem and you think it's coming through their audio cables, then that would help.
Okay.
Um, you can actually buy cables with these chokes already installed. They cost more. You'll see them, like particularly USB cables, and they'll have a lump on each end. That's a ferrite bead. It's easier to put the clip-ons. They're not quite as effective because there's a gap in the uh, ferrite material. Uh, if you're picking up hum, particularly when you're transmitting and people are telling you that you have some hum in the background, it could be due to a ground loop, uh, which is essentially you've got more than one connection between devices, which can kind of form an electrical loop. which can act like an antenna and receive signals, particularly 60 hertz AC, which you don't realize it, but that's a pretty strong signal all over the place. If you looked at it with a spectrum analyzer and an antenna, you'd see all that hum if you could go down that low. Most spectrum analyzers don't necessarily go down to 60 hertz. Uh, Also, when you ground your equipment, you should never daisy chain things, which means I've got 3 or 4 devices and I connect a ground wire from one to the next one to the next one, eventually to some ground point. That's called daisy chaining. You want to have a connection from each device to a single ground, preferably some sort of uh, copper plate or copper bar where everything can be tied to it and it has a very low impedance. And that should be
That should be
connected
connected
to an
to.
external ground.
So if I understand right, daisy chain is kind of like what I do with my extension cords.
Yeah,
No,
it's bad practice both ways.
Yes, I understand that.
Um, you want to keep ground wires as short as possible, um, which is part of the direct. You also want to avoid having loops or 90-degree bends because actually you're adding inductors, which we'll talk about next week. Um, you can wind up with a ground connection that just so happens to be the, say, a quarter wavelength or a full wave or half wavelength of some signal. So it would become resonant and you could generate a high voltage. It's kind of acting like an antenna. At high frequencies, it doesn't take but a very short piece of wire to become a resonant antenna. Most of your devices will be in at least partially in a metal enclosure. And you want to make sure that you ground all those enclosures. If they're all plastic, then you can't really ground it. But it may have a ground connection on it, like on the back of most radios, there where you can connect it to ground, even if all of the chassis is not metal.
So we're even grounding our radios in the house. Not,
Yes,
yes. So
yes,
you need to go to an outside ground, Winthal.
yes.
Okay.
Um, and you can tie all the enclosures together, assuming that you've got them going to a single point ground, so that even though they're going to a single point ground, the length of your ground wires may not all be the same. So you could still wind up with a difference in potential on the different devices because of the length of the ground wire, and there will be some inductance and resistance in that wire. So tying them together would also help equalize the potential. And that's the whole point, is you want everything, particularly for lightning strikes, to be at what we call equipotential. So everything is at the same voltage and goes up and down with a lightning strike. So there's no difference uh, uh, and no difference in electromotive force between one device and the other. So there won't
Okay.
be any current flow.
So just to confirm, if you have your antenna, if what you're trying to do, you can do an antenna in your attic.
Right.
Your radio is in the house as well. You still need to go out to ground with it. Because I thought if everything was enclosed in the house, that almost eliminated the critical need to go out to ground. Is that not correct?
Well, it helps eliminate it, but you should still, for noise and other reasons, you should still be connected to an external ground rod outside.
Okay, so you're more protected by lightning if everything's in the house, but you'll still have maybe hum and that noise interference that you could help by going out to ground.
Yes, even though your antenna's in the attic, if you had a lightning strike close by, you could have enough induced voltage on that antenna to fry your equipment.
Okay, all right, thanks.
What do you mean by bonded?
Physically connected,
Okay, thank you.
usually with some sort of clamping device like a bolt nut type thing. Um, I think it's probably coming up on the next slide or two. You do not want to use soldered connections, particularly for any ground wire that um, might be carrying current as a result of a lightning strike, because you're talking about potentially thousands of amperes, uh, and solder would vaporize, and you no longer have a connection. Whereas you have a physical crimped or a welded connection, um, it could withstand the current. Um, Once again, you want to try to avoid right angle bends. You want to have either heavy gauge wire or flat strips. Um, I use outside copper strap that's 2 inches wide. It has a lot of surface area, and that's where the current actually flows on the surface. Um, Inside, I use fairly wide braided uh, wire, which also has a lot of surface area, and it's still flexible. And like I said, you want to make sure that you either have clamped or welded connections. A lot of people, when they do connections to ground rods, and you can have multiple. In fact, ideally, like for a commercial installation, you would have ground rods and ground wire around the whole circumference of the property. You can actually get this material, it's like a thermite, and put on those connections, and it actually um, sort of burns, creates enough heat that it actually makes a welded connection. It's not solder, it's physically welded. It melts the metals together. Um, there's a lot of broadband electrical noise, motors in particular, especially motors with brushes. They're kind of like the old spark gap transmitters, which is how we first transmitted radio, by making a voltage jump a spark jump an arc between 2 points, and doing that on and off is how they first generated Morse code. Uh, you can get that from insulators arcing over on power lines. The transformers are on the insulators on the lines, particularly around here close to the coast where you get a lot of salt. That's why they go around and wash them off, because that salt causes them to arc over and generate a lot of broadband noise. Electrical connections that are not tight, and you can have some arcing there, does the same sort of thing. Any questions on those? There wasn't a lot of material, so it shouldn't be hard.
Good.
Okay, so which of the following might be useful in reducing RF interference to audio frequency devices like speakers and stereos and things?
Capacitor
I
and
think is it Bravo?
Bravo.
Bravo. Um, Actually, the ferrite beads uh, don't have as much effect on the very low frequency devices because the inductance or reactance uh, of them is much lower at low frequencies. The reactance increases as the frequencies go up in an inductor. So they work better inhibiting higher frequencies. Whoops.
Yeah, it's arcing. Yeah.
You
That's
knew
what I was
this one,
gonna
right?
say.
Yeah, you just said it.
What sound is heard from an audio device experiencing RF interference from a single sideband phone transmitter?
Charlie.
Anyway,
Charlie or Delta. Yeah.
That would be something different.
Mm.
Would really
Mm.
be results of a ground loop somewhere.
What would be?
A steady hum when your transmitter's
Yeah,
on.
yeah, yeah. Hmm.
What sound is heard from an audio device experiencing RF interference from a CW transmitter?
Alpha.
Alpha.
Right. What is a possible cause of high voltages that produce RF burns?
not A, not B, not C.
Delta.
Yeah, Delta.
Yep. And I understand, I haven't had one. I understand RF burns are especially bad, very painful. So you don't want to go touch the end of your antenna when it's transmitting. What effect can be caused by a resonant ground connection?
Not A.
Alpha. Charlie.
Charlie. Charlie.
Is it
I'll
Delta?
take it, Charlie.
Okay, take a Charlie.
Higher.
Yeah, we talk about resonance next week,
Caused by
but
resonant ground
a resonant
Oh,
device,
yes.
depending on whether it's
Yes.
series or parallel, if it's a parallel device, at resonance, it's going to have a very high impedance. So it can develop very high voltages across it. Whereas if
Yeah,
it
it doesn't.
was,
Yeah, gotcha.
okay. Why should solder joints not be used in lightning protection ground connections?
Alpha.
Alpha.
All of these choices are correct.
Alpha.
Alpha.
Well, hopefully you remove the solder flux.
Yes, right. That was the end of that.
But even if you didn't, it's not going to cause a problem. And
We don't even know what dielectric is.
not yet, but solder doesn't have much of a dielectric constant. it's pretty much a conductor, not a dielectric. Which of the following would reduce RF interference caused by common mode current on an audio cable?
Alpha.
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 Yeah, and I didn't mention common mode. Do you understand common mode?
No.
No, we
Okay.
just eliminated that word.
That's good. You have to think on these sometimes. Common mode is if you have two wires connect in a circuit, say go into a light bulb. Convention is that you have current flowing on out one wire and back on the other, and those currents are equal. If you have some interfering source that's inducing a voltage on those wires, it can create a current that's traveling in the same direction on both wires, in
Oh,
addition to the current that's going up and back to your light bulb.
so
That's
they would
called
be
that's
interfering with each
called
other.
common mode because it's the same
The same
direction. It's not
direction.
differential.
Okay,
So if you put a ferrite bead around those two cables,
it's gonna
okay,
cut it
it
off.
acts like an inductor to both of them, so it blocks the common mode,
Right.
but it won't block the uh, signal going out and back, particularly on
Okay.
coax, because on coax, the common mode is actually going to travel on the outside of the shield. And we'll talk about that sometime later on how you can have current on the inside and the outside of the shield at the same time
Okay.
that are different. Actually, like two wires. How can the effects of ground loops be minimized?
Delta.
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 And ground loops are hard to track down. That's one of the things you can do, but once you have a ground loop, it can really be a bear to try to figure out what's causing it. What could be a symptom caused by a ground loop in your station's audio connections?
Alpha. Alpha.
Yep, alpha.
What technique helps to minimize RF hotspots in an amateur station?
Isn't this a repeat, Charlie?
Charlie. Yeah.
Charlie
Or
sounds good.
answers a repeat, you know.
Although I would have said there's a little truth in alpha.
Mm-hmm.
Yeah, because you put them in the middle
Although
and
you
put,
still need to connect them together for it to
yeah.
work. Why must all metal enclosures of a station equipment be grounded?
Delta.
Delta.
Yeah, if you have a very low impedance connection to ground from the chassis, you can't develop a very high voltage. Oh, that was a nice quick one.
Don't forget your recorder.